Hi, today we're going to be working with angles in standard position on the unit circle. So we've worked with angles before and we've worked with XY axis before. Now we're putting those together. So first of all, what we need to understand is standard position for an angle. We have one of the sides that is on the x-axis. This is called the initial side. And then to show the rotation of the angle, it's like how far you're rotating this side around. You use an arrow to show which way it would be. Now, we know that from here to here is 180, and this is probably maybe another 30 more, so 180 plus 30. So this angle, starting from here, the initial side, all the way around to the terminal side, we'd say it's about 210. And if you were to keep going, remember it's 360 to make a circle. Now, if you started at the initial side and you went the other direction, you would be rotating in a negative. We would say that would be a negative rotation. So the size of that angle would be a negative, let's see, 210 minus, 360 minus 210 is 150. So we know that from here to here is 90. If this was 30, this would have to be 60. So 60 and 90 is 150. And we would say that would be a negative rotation. So this is your initial side. This is the terminal side. The measure of an angle in standard position is the amount of rotation from the initial side to the terminal side. All right, what are the measures of each angle? Now I'm going to go into another slide right here, and we're just going to look at this graph because it's kind of neat. Okay, so there is a 36-degree angle right there. There would be 45. It's hard to get it to stop right on 45, but that's about 45. Going all the way up to the y-axis there, the positive, that would be 90 degrees. Okay, keep going around. There is 180. Keep going around. There's another 45, so that would bring us to, did I miss it? I might have missed it there. We'll just keep going. Oh, when we go 3/4 of the way around, that's 270. And then we keep going around, and then that would be 0 or 360. Okay, let's go back to our screen. So in this one, here's your initial side, your terminal side. That would be a 90 degrees rotation of the initial side up to this point right here. Now in this one, just so that you understand this, if this point right here is at -2, -2, -2, okay, that means that this length is 2 and this is 2. So if we were to make us join those, we would have a square that's 2 by 2. And we know from your geometry days that the diagonal bisects the angle. So this was 90, so this would be 45. So, and we know this is 90. So the size of this angle, we can compute that exactly, is 90 plus 45, which is 135 degrees. Now, because it went this direction, it would be a negative 135 degrees. All right, what is the measure of the angle shown? So again, we know this is 45, and we are going this direction. So from here to here is 180 plus 45, and that would give you 225. I should write it right here. 225 degrees. That's where we usually write the size of the angle. Okay? What is this? What is a sketch of the angle? So these are, we're going to be ballparking these a little bit. So first we draw the initial side. And let's see, now if we went right here, that's like halfway, so that's 45, and 36 is below that, so it would be like about there maybe. And then we draw the angle to show the direction because it's positive, and that would be 36 degrees. That's how you do that. Next one is 315 degrees. So let's draw the initial side, and we have to think about this now. Let's see, this is 90, this is 180. Another 90 would bring us to 270. So we have to figure out like how much past 270 are we going to go? And so let's just subtract that and see about how much further we go. 315 minus 270 is 45. So that tells us we're going to go halfway. Okay, halfway here. So, and then we draw the arrow to show the direction. So then we would write that this is 315 degrees. All right, next one is 850. So negative 150, excuse me. So there is our initial side, and that it's negative, so we're going this direction. Now this is 90. So how much past 90 are we going to go? So 150 minus 90 is 60 degrees. So we have to go another 60 degrees, and so that would be like 2/3 of the way. And so we would say that this is negative 150 degrees. Okay, what is the sketch of an angle in standard position? So 85 degrees, all right. So there's your initial side. 90 degrees is right here, so it's just below that. It's quite a straight line, but you get the idea. And so this is 85 degrees. Negative 320. So here's my initial side. We're going to go back 270 degrees. So 270, or 320 minus 270, let's see what that is. That would be another 50 degrees. So it's just a little more than halfway. Let's see, so like right here maybe. All right, because this is 45, so it's a little more than 45 degrees. So negative 320 degrees. Next is 180, so draw your initial side and goes around 180 degrees. Draw your terminal side, and there we go, 180 degrees. All right, so that's drawing the angles. So now, two angles in standard position are coterminal if they have the same terminal side. All right, so here you have a 135-degree angle. Okay, so this is your terminal side. Okay, now if you went the other direction, it would be 225 degrees, negative 225 degrees. Okay, and that angle, negative 225 degrees, has the same terminal side. So we would say that 135-degree angle and a negative 225-degree angle are coterminal angles. Now, you can have an infinite number of coterminal angles, because if you are at 135 degrees, and if you go around another 100 or 360, excuse me, so that would be 135 plus 360, that would be 495 degrees. Okay, so we would say that those are coterminal angles. And you can continue, you can go around again another 360 degrees. So 495 plus 360 is 855 degrees. So you can just continue adding 360 to get coterminal angles. As far as that goes, let's say that you are at negative 225. So if you're right here, and so we're going around negative 225, you could subtract 360 from that angle. Also, so if you have negative 225 minus 360, so you can go back the other direction, negative 585. Or if you were at 135, so at this angle, and you went back 135, so 135 minus 360, you would be at negative 225, which is where we were. So you can either add 360 to an angle or subtract 360 to an angle, and you'll end up in the same place. So that's how you get coterminal angles. Which of the following angles is not coterminal with the other three? So 300, let's see, that would be 180, 270, it would be another 30 degrees, so that would be your 300-degree angle. Okay, so this is 30 right here. I'm going to write that. It's really hard to see there. If we went a negative 60, that would be, those two would be coterminal, because 30 and 60 makes 90. So these are coterminal. The next one is 60 degrees. Well, 60 degrees would be right here. Oh, no, probably right there. Here's a 60-degree angle. Well, that does not have the same terminal side, so it's not that one. And then negative 420. Let's just look and see where that one is at. Let me pick a color I don't have here. Oh, I've got most of them, I guess. We'll do black. Okay, negative 420. So we would go around 360 degrees. So 420 minus 360. We would have to go, so we go around 360 degrees, plus we'd have to go another 60 to make 420. That one is going to have the same terminal side. So angles A, B, and D are coterminal. They all have the same terminal side. All right, next, find the measure of an angle between 0 and 360 coterminal with the given angle. So what you do to do this is you add 360, and that would give you 400 degrees, and that's not between 0 and 360. So the other option would be to subtract 360. That would be negative 320 degrees. Actually, neither of those are right between 0 and 360 that are coterminal, but those are both angles that are coterminal. So next one, 125, you add 360. So that would be 485 degrees. And 125, you can add or subtract 360. Which is a negative 235. And you can continue, oopsie, I'm having trouble writing here. Negative 235. Negative 235. And you can continue subtracting 360 from each number or adding 360 to just get an infinite number of coterminal angles. So then the next one, you have negative 40. You can add 360. So that would be 320 degrees. Or you could take negative 40 and subtract 360. So that would be negative 400. Those are both coterminal. All right, so now we're going to work with angles in standard position on the unit circle. So I'm just going to put a circle around, put a circle in that has a center at the origin. Now we know that the distance from here to here is called the radius. And this point, the location of it, we would have to go over some x units, and then we would have to go up y units. Let's see, let me write that again. We would go up y units, okay, to get to this point. So over x, up y. With that, here's what we can do. We can drop down a side that is perpendicular, okay, and make a right triangle. And with a right triangle, we can use trig to find out information about this angle. If we know the angle, we could find missing lengths, and so we can use our SOHCAHTOA. And actually, we're going to learn some new trig functions too to find out a lot of information. And this can be used to solve problems in real life. So we call this a reference angle right here. So if this is the angle, this is called a reference angle. And to make a triangle, what you do is you put your pen on a point and you draw an angle, draw a line that's perpendicular to the x-axis. So now if you have an angle that looks like, let's see, let's make it about 135. So if it's an obtuse angle, pick a point. And to make the reference angle, or the reference angle would be the angle that is formed from the line to the closest x-axis. So to figure out like your trig functions, you would use this angle, and we would make a triangle out of this. So you always pick a point and go to the closest x-axis, okay? All right, so let's look at this now. So here we have an angle. This is theta. This is called our reference angle. Okay, so if we go from a point to the closest x-axis, this is the angle right here that we're using. Now we have more trig functions. You know SOHCAHTOA, sine, cosine, and tangent. So sine is opposite over the hypotenuse, cosine is adjacent over the hypotenuse, and tangent is opposite over the adjacent. So there are three more trig functions that we did not talk about probably last year in geometry, and that is cosecant, which is actually the reciprocal of sine. It's hypotenuse over opposite. Secant is the reciprocal of cosine, the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent, the adjacent over the opposite. Now, tangent and cotangent are reciprocals, and that's nice. They name those closely, so those are easier to remember. The thing that's funny is sine and cosecant go together. They are reciprocals. And cosine and secant go together. It would have been really nice if when they did this, they put sine and secant together because they both start with the same letters, and cosecant and cosine together, but they don't. So you just have to remember the sine and the cosecant go together, S and C, and the cosine and the secant go together, C and S. All right, so let's do some problems here. Use the given point on the terminal side of an angle theta in standard position to evaluate the 6 trigonometric functions of theta. So here's what we do. This is called our reference angle. This is the point that is on the circle. Okay, it's also on the angle. And we're going to use trig functions. We need a right triangle. All right, now this is your x, this is your y. We're going to go over x units and up y units to get to that point. Okay, so the x is 3, the y is 4. It tells us we went over 3, up 4. Now, you don't have the radius written down here, the hypotenuse, but we have a right triangle, so we can use the Pythagorean theorem. Remember, x squared plus y squared equals c squared, or a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared, 25 equals c squared, and if you take the square root of both sides, your hypotenuse is 5. So those are your sides, 3, 4, and 5. Now, if this is the angle that we're using, this side is the opposite, this is the adjacent, and this is the hypotenuse. So now we just have to write in the trig function. So sine, remember, that's opposite over hypotenuse. And so the opposite is 4, the hypotenuse is 5. That's it. Cosine is the adjacent over the hypotenuse, and that would be 3 over 5. And tangent is opposite over adjacent. The opposite is 4, the adjacent is 3. Okay, now let's go to our new functions, cosecant. So that is the reciprocal of sine, so that's the hypotenuse over the opposite, so that would be 5 over 4. Secant is the reciprocal of cosine, that is the hypotenuse over the adjacent, so that would be 5 over 3. And cotangent's reciprocal of tangent, so it's adjacent over opposite, so that would be 3 over 4. And that's what we do for this. All right, let's do some more problems here. Next, let negative 4, 3 be a point on the terminal side of an angle in standard position. Evaluate sine, cosine, tangent, secant, cosecant, and cotangent of an angle. Now, this is your theta. This is the degrees, but this, we always go from this point. We use the reference angle, which would be this one right here. Now, to get to this point, you would go back negative 4, and now this is a distance, so technically that's a positive length, but we keep it rated as a negative because that's what's going to give us this correct sign for the angle. And when I say sign, I mean positive or negative. And then here you would go up 3, and we have to do the Pythagorean theorem to find your hypotenuse. So it would be 3 squared plus, and in parentheses, a negative 4 squared, the whole thing is squared, equals c squared. And so again, your c is going to be 5. Okay, and so we have sine of the sine, we'll call it theta, cosine, tangent, and then we have secant of theta, cosecant of theta, and cotangent. So the sine is opposite over hypotenuse. So the opposite, and again, label these if this is hard for you at all. Here's your opposite. This is your hypotenuse, which is 5, and this is your adjacent. Okay, so sine is opposite over hypotenuse, so it's 3/5. Cosine cosine is adjacent, which is a -4. -4 over 5. Tangent is opposite over adjacent, which is 3 over a -4. So it's -3/4. Secant, remember that's the reciprocal of cosine. So that would be the hypotenuse over the adjacent. So that would be 5 over -4. Cosecant is the reciprocal of sine. So that's the hypotenuse over the opposite. So that would be 5 over 3. And then cotangent is the reciprocal of tangent, adjacent over opposite. So that would be -4/3. Okay, there we go. There's another problem. All right, next, we'll just do one more here. Let's go ahead and pick one that is in the fourth quadrant. We haven't done one like that. So again, put your pen on the point and draw a line to the closest x-axis, which is this one. And then this is the angle we're going to use. Now, this is the point is at 3, -3. Here's your x, here's your y. So you're going to go over 3 and down 3. Okay, and then do the Pythagorean theorem. So you have 3 squared plus -3 squared equals c squared. And we're going to keep this in root form, so we're exact. So 18 equals c squared. Remember how we simplify roots? We need to look for perfect square factors. That would be 9 times 2. And the square root of 9 is 3. So that would be 3 root 2 is your length of c. Okay, so now from there, we're going to do your trig function. So the sine of theta, this is your opposite, this is your adjacent, here's your angle, here's your hypotenuse. So sine is opposite over the hypotenuse. Oh, this is a little bit messier. We've got a root in the denominator. So I'm going to cancel the 3, so that's a -1 over root 2. And remember, if you have a root, we can't have that. We multiply it by itself. So we end up with negative the square root of 2. And that's the square root of 4, which is 2. Let me erase this right here. All right, now we have the cosine of theta. Cosine is the adjacent over the hypotenuse. And again, cancel, so there's a 1 there. So it's 1 over root 2. And I'm going to multiply by root 2 over root 2. So 1 times the square root of 2 is the square root of 2 over 2. And then we have tangent of theta. That is the opposite over the adjacent. And that's a -1. And then we have secant of theta. And sometimes I write these down. That's the reciprocal of sine. So that's the hypotenuse over, nope, not of sine, of cosine, excuse me. That's the hypotenuse over the adjacent. So the hypotenuse is 3 root 2 over 3. And the 3's cancel, so that's just the square root of 2. And then the cosecant of theta, okay, that's the reciprocal of sine. That's the hypotenuse over the opposite. So the hypotenuse is 3 root 2. The opposite is -3. And those cancel, so you just have a negative and then a root 2. And lastly, the cotangent of theta is the adjacent over the opposite. And that gives you a -1. All right, so make your triangle and then just fill in the numbers and simplify. Okay, remember when we worked with 30, 60, 90 triangles, all of them are similar, which means they are proportional. And the side across from the 30, the smallest angle, has a ratio, or let me start over. The ratios are 1 to root 3. The side across from the 30 is 1. The hypotenuse is always a double, and the side across from 60 is the square root of 3 times larger than the short side, the short leg. So 1, 2, and root 3. Remember, root 3 is approximately equal to 1.7, so that's your medium length side. And then a 45, 45, 90 triangle, those all have the extended ratio of 1, 1, root 2. The sides are the same because 45, 45, 90 is an isosceles triangle. The base angles are congruent, so the sides across are congruent, so those are the same. The hypotenuse is the square root of 2 times longer. Now we're going to use those pieces of information, write those down if you don't have those memorized, to solve problems here. So here's an example. Evaluate the trigonometric functions for each angle. First thing you want to do is draw the angle. So 135, here's my initial side. Let's see, if you subtract 90, you get 45. So we're going to go up 90 plus another 45 degrees. So this is a 135 degree angle. So to find the trig functions, we're going to use the reference angle, which is this. So 180 minus 35 is 45. So that's a 45 degree angle. We're going to pick a point right here and drop a line, okay, to make a right triangle. Now, if this is 45, this is 90, this is 45. So we have a 45, 45, 90. The sides of a 45, 45, 90 are 1, 1, and root 2. So we're going to put a 1 and a 1 and a root 2. Okay, now here's the one thing you have to remember is your signs. You have to look at the location of where this angle's at, where the reference angle is, okay? You would have to go back 1 and up 1. So this, you're going to put a negative right there, okay, just to show the location. So now we can do our trig function. So sine of theta, excuse me, I'm not going to say theta because we know what that angle is. So the sine of 135, okay, because that's what we're looking at. This is the actual angle we're solving for. That is the opposite over the hypotenuse. Okay, and again, we can't leave the radical in the denominator, so we multiply by root 2 over root 2. And that would be the square root of 4, which is 2. Now, I just want to show you this. If you put in your calculator the square root of 2, divided by 2, you get 0.707. Now, if you type in your calculator sine of 135, you get 0.707. So what we did is we just figured out the side of an angle without using a calculator. All right, now let's do the cosine of 135, and that would be the adjacent over the hypotenuse. And again, we multiply by root 2 over root 2. And there's your answer. The tangent, right, let's do tangent of 135 is opposite over adjacent, 1 over negative 1, so it's a negative 1. All right, and then we'll do the cosecant, which is of 135, which is the hypotenuse, square root of 2, over the opposite, so it's just the square root of 2. The secant of 135 is the hypotenuse over the adjacent, so that would be negative root 2. And then the cotangent of 135 is the adjacent over the opposite. There you go. All right, 240. I do not have room here for all of this. Let's go do that one. All right, and we will just draw this and set it up, and then you can go ahead and do your trig functions. So 240 degrees. All right, so that would be, here's your initial side. So we would go around 180. Let's see how much further. 240 minus 180 is 60. We have to go another 60 degrees. So this is 60 degrees. Okay. Keep track of what that is, and now pick a point, draw a line right here. So you have a 30, 60, 90. The short side is 1, the hypotenuse is 2, and the long leg is root 3. Now, as far as getting signs, you have to just pay attention. To get to this point, you would have to go a negative unit, so put a negative here, and down negative units. So those are both going to be negative. And now you can do your trig functions on that triangle. Let's draw the negative 30 degree angle. So here's your initial side. 30 degrees is about like here. Okay, we're going down 30 degrees. And we'll put a point here, make our triangle. Okay, so 30, this would be a 30, 60, 90 again. The short side is 1, hypotenuse is 2, and the long leg is root 3. So here we're going to go over a positive value and down. So this is a negative. Now, because of the Pythagorean theorem that you would use to find the hypotenuse, the hypotenuse is always positive in these problems. All right, that's it for this lesson. Thank you for watching.